All right, our DLO for today is I will learn how to solve inequalities. So go ahead and write that down. And we're going to look at your packet for this page. It says solving inequalities, single and multi-step classwork. I believe it's on page 46 in your packet, maybe 47 actually. Yeah, I think it's page 47 in your packet. So today we're going to look at solving inequalities. In the past day or two, we've only been looking at making sure that we can set up inequalities or that we can evaluate inequalities. But today we're going to work on solving inequalities just like we have worked on solving equations in the past. So in solving equations, we had these four properties of equations or four properties of equality that we could use. Let me get back to that really quick. Oops. There we go. We had these four properties of equality that we could use, and now we're going to use the four properties of inequality. So they're exactly the same as the properties of equality. The only difference is now they say inequality at the end of them. So here you see it says inequality, 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 inequality. But pretty much we go through them really quickly step by step. You don't need to write all of this down as long as you have it in the back of your memory that these are the reasons why we're allowed to do the things that we do. The addition property of equality says that if you add something to one side, you're allowed to add it to the other side. So you guys have heard that again and again. Whatever you do to one side, you have to do to the other. So that comes from these properties. So the addition property of inequality says if you can add something to one side, you can add something to the other. The subtraction property of inequality says if you subtract something from one side, you have to subtract it from the other side. The multiplication property says if you multiply something to one side, like we did here, we multiplied C all over there, then you have to multiply it to the other side as well. And last but not least, the division property says if you divide something on one side, you have to divide it on the other side as well. So you guys can kind of see as we go through here that there's a pattern. Whatever you do to one side, you have to do to the other. Oops, a little too fast. All right, so this is very important here. So I'm going to give you guys a minute to go ahead and write this down. So I want you guys to write down this right here. This is called set notation. And so a lot of your answers are going to be asked for in set notation. So pretty much it starts out all the same. So let me kind of go through with this blue color, and I'll kind of show you what happens. So these open curly brackets that you have here, all right, everything that's in set notation always looks like that. You always start it with whatever variable you're using in the equation. So in this equation we're using x. Sometimes you'll have different variables, but that's the variable they're using here. And this is the part that's going to change. So everything's going to look exactly the same every single time, depending on if you're using a different variable. But here, what's inside my circle is what's going to change. So whatever your answer to your problem is, that's what goes here where I've highlighted with the circle. So in this case, it's x is less than or equal to 1. Your answer might be different than that. X is greater than 1, x is less than 4, so on and so forth. So you guys can kind of see an idea of what it would look like to have something in set notation. So again, make sure you have all that written down. A lot of your answers will come from that. So if you haven't finished yet, please go ahead and pause the video and then we will continue. All right, so down here, if you look down here, this is also very important. So go ahead and write this down as well, because in addition to asking for your answer in set notation, the problems that we're going to be working on are also going to ask you to graph it. And so we're going to go ahead and do that really quick. So pause the video again and write down what you see over here inside this circle. Take a few minutes to write that down and then unpause it to continue. All right, so if we can read that again, it says, to represent greater than or less than, mark the endpoint with an empty circle. So if you look here, this is x is greater than 1 for the first one, so that's done, empty circle. This one down here says x is less than 1, so that one is done as well, empty circle. For the next one down, it says to represent less than or equal to or greater than or equal to, mark the endpoint with a solid circle. So for those ones, we are actually going to have to fill them in with a solid circle. So notice here on x is greater than or equal to 1, I'm going to go ahead and I'm going to fill that in. So notice how I'm filling in that black dot there. So now that's a solid circle. All right, and then down here at the bottom as well, x is less than or equal to 1. I'm also going to fill that in with a solid circle so that both of those are represented correctly. All right, good. So now all four of them, are all good. The ones that are greater than or equal to or less than or equal to are shaded correctly now with a closed circle. If it has that equal to symbol, it has to be a closed circle because it's allowed to equal that point. Over here, it says shade the part of the line that contains the solution set. So obviously here it's x is greater than 1, so we're going to shade greater than 1. X is greater than or equal to 1, so we'll shade greater than or equal to 1. X is less than 1, so we'll shade less than 1, or x is less than or equal to 1. So that's why we shade less than or equal to 1. All right, make sure you have all that copied down, and then we'll move on. All right, we're going to look at 3 examples on the next page. So let's come over here. We're going to do number 1, number 2, and number 7. So it says solve. So there's a couple different things we have to do. The first one says solve, then justify your steps, then write the solution in set notation, then graph your solution. So we have 4 things to do. So let's start with this first one over here. It says solve. So we're going to solve these exactly like I wanted to solve my equations from last time. So actually let me zoom into this a little bit so you guys have a better view of it. Oops. All right, so we're going to solve these exactly like we solved our equations from last week or the week before. So the first thing I want to do is I want to isolate that x. So I'm going to get rid of that 1 by subtracting 1 from both sides. So minus 1, minus 1. And that is called the subtraction property of equality. So I'm just going to abbreviate subtraction property of equality. All right, and then when I simplify, on these sides I have additive inverses, so those are going to add to 0, so I get x is less than or equal to negative 3. So we did the first part, we solved it. We did the second part, we justified our answers. That was this part here where I put the subtraction property of equality. That was the justification. Here was solving it. Now let's do set notation. So remember, for set notation, I have my little squiggly brackets. I have an x, then that line, that bar, such that x is less than or equal to negative 3 and a squiggly bracket. And again, that x is less than or equal to negative 3 just came from right here. So whatever it equal to went inside there. All right, so I did solving it, I justified my steps, I did my set notation, and then the last thing I'm going to do, which actually I just wrote it in the wrong place, but that's okay. The last thing I'm going to do is to graph it. So I have this number line here, I'm just going to draw another one so we have room. And I'm going to graph x is less than or equal to negative 3. So I'm going to find negative 3 on my number line. Here's 0, here's negative 1, here's negative 2, here's negative 3. And I want it to be a closed circle because it's less than or equal to. So I have that equal to symbol makes it a closed circle. And then less than negative 3 would be all the numbers less than that, like negative 4, negative 5. So I'm going to just shade going this way. And I am actually going to write it like that. So you're going to see me writing it like that. Because if you just draw it right on top of the line, it kind of gets hidden in the line. So I'm going to start shading it on top of the line like this. All right, and so we did all 4 things it asked us to. We solved it, we justified our steps, we wrote it in set notation, and now we just finished graphing it. So those are the 4 things we're going to have to do for each one of these problems. So let's work on number 2 together now. So go ahead and pause this if you haven't finished it yet, and then we'll work on number 2. All right, here's number 2. 4x is less than 32. Again, the first thing it wants me to do is to solve it. So I'm going to get that x by itself. Right now 4 is being multiplied times x, so I'm going to divide by 4. Just a little side note right here. I'm not going to go into it in too much depth right now, but if you ever had a problem where you had to multiply or divide by a negative number, you just have to remember that you have to switch the sign. So if this was dividing by negative 4, then this would switch from less than to greater than. So whenever you're multiplying or dividing by a negative number, you always have to switch the sign. Right now we're dividing by a positive number, so we're okay. We don't have to switch it, but just keep that in mind. Multiplying or dividing by negative means to switch the sign. So this is the division property of equality, or of inequality, I should say. Division property of inequality. Sorry, I wrote that wrong in the first one. Division property of inequality. So when I simplify 4 divided by 4, those are multiplicative inverses, so those simplify to 1. So I get x is less than 32 divided by 4, which is 8. All right, let's see so far. We've solved it. We've justified. Let's write it in set notation. My little squiggly brackets, x bar, so x such that x is less than 8. And again, I got that part from right there. All right, so we solved it, we justified, we wrote it in set notation. The last thing is to graph it. So I have 0, 1, that's a 1, 2, 3, 4, 5, 6, 7, 8. So here I have 8. It's not less than or equal to, it's just less than, so I'm actually going to leave this as an open circle. And less than 8 means like 7, 6, 5, 4, 3, 2, 1. So I'm going to write my shading this way. All right, so x is less than 8. All the numbers this way from 8. So we solved it, we justified, we wrote it in set notation, and then we just graphed it. Good to go. Let's work on our last problem, number 7. You can use it as example 3, though. Alright, so it says, Jessica makes overtime pay when she works more than 40 hours in a week. So far this week she has worked 29 hours. She will continue to work H hours this week. Write, solve, and graph an inequality to show the values of H that will allow Jessica to earn overtime pay. Alright, word problems are always difficult, so I read it once by itself, and then I'm going to go back through and I'm going to highlight things that I think are important in this problem that are going to help me solve it. So, let's see. Jessica makes overtime pay when she works more than 40 hours. Alright, more than 40 hours, that's important. So far in this week, by the way, you should write this problem down to have it in your notes. So far this week she has worked 29 hours. So far she's worked 29 hours. She will continue to work H hours this week. Write, solve, and graph an inequality to show the values of H that will allow Jessica to earn overtime pay. Alright, so in the previous days we've defined a variable, so I'm just in the habit of defining a variable even though they've already done it. So H equals the hours worked. Alright, if I'm going to write an inequality to help me out here, I've already worked, or I should say Jessica has already worked 29 hours, and she's going to work H more hours this week. Now, the tipping point or the balancing point is 40 hours, because we're trying to figure out how much more she has to work in order to earn overtime pay. So that tipping point is 40 hours, because as soon as she works 1 hour over that, she earns overtime pay. So I'm just going to write 40, and we need to be able to fill in something here in between those two numbers. So it's either greater than or less than, greater than or equal to, I should say, less than or equal to. So let me think about this. 29 hours plus H blank 40 hours. And we want it to be more than 40 hours because we want her to be earning overtime pay. So how would I represent more than 40 hours? Well, I'd probably say that it has to be greater than 40 hours. Now, it can't be equal to 40 hours because at 40 hours she doesn't earn overtime pay. So it has to be greater than 40 hours. Alright, so we wrote it. Now we have to solve and graph it as well. So to solve this, I'm going to use the subtraction property of equality to subtract 29 from both sides. When I simplify, these are additive inverses, so those add to 0. So I get H is greater than 40 minus 29, which is 11. So if she works more than 11 hours, she gets paid overtime. More than 11 hours, she gets paid overtime. Let's see if that makes sense. 29 plus 11 is 40. So if she worked 40 hours, she would be good. If she worked more than 40 hours, she would be in overtime. So more than 11 hours would be overtime. That's perfect. So we wrote it, we solved it, now we have to graph it, the last step. So I'm just going to graph it up here. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, and she has to work more than 11 hours, so I'm going to open circle at 11, because it's not equal to 11 hours. She has to work more than that. And my arrow's pointing this way, at more than 11, or H is greater than 11. So once you're done with that for today, go ahead and finish up, and we'll see you tomorrow.